Here we go. How's everybody doing today? I hope you're having a spectacular day and we're looking forward to another stimulating, outstanding, I hope, math lesson. Week 3, lesson number 1 for this course, Math 1200, Math Applications in the Real World. We're not going to do a ton of new stuff today. What we're doing is we're trying to get you ready for a project. Here's your homework answers. Take a look. Remember, do stop and start. If you have any issues or questions with these, then bring them up to me. Number 1, 2, pretty straightforward. You've done a lot of those. Number 3, can a triangle whose sides measure 8, 8, and 19 exist? Why or why not? It cannot. The sum of any two sides must be greater than the third. 8 plus 8 is not greater than 19. Then we've got to distribute and simplify. Remember, by the order of operations, you have to multiply before you can do any combining like terms. Okay. Number 5, find the sum of the two decimals and explain how and why you did it. Again, I want to emphasize that on graded work in this course, I am not going to give you decimals to add. Now we're a little bit above that, but I am going to ask you why you're doing certain things. What is the strategy? Why did that technique develop? I made sure to line up the decimals so like types or terms or whatever you want to say, hundredths with hundredths, tens with tens, thousandths with thousandths were being added. Next one is to add. Be sure to show all work and explain why you did it. And this is the subtraction of two fractions with anytime you add or subtract, which is just adding the inverse. You need to make sure that you have a common denominator, which is a common category. So the work is shown right there. Okay. Remember our technique of saying, well, if I didn't realize that 12 was the least common denominator, which a lot of students don't because students are not as good at fractions as they used to be, then I can just take the 3 from the bottom here and write 3 over 3, the 4 from the denominator here and write 4 over 4. Okay. Try these next ones here. Pretty straightforward. Okay, number 6 gets into something from the last lesson that we had, which says explain why -3 plus -8 is -11. And a negative is a type, it's a category. So if I have 3 things that are negative and 8 more things that are negative, then altogether I have 11 things that are negative. Similar to the idea that if I had 3 trophies and 8 trophies, I would have 11 total trophies. Okay, explain why 5 times -9 is -45. Well, it's kind of like distributing, even though it's not distributing. Basically, when you multiply by a negative, you're multiplying by the number component of that and the negative component. The number component just gets you 45, right? 5 times 9 is 45. But anytime you multiply by a negative, you have to change the sign you started with. So +5 becomes -45. And there's the solutions for number 7, A, B, and C. When you look at number 7, remember for part A, you multiply coefficients, add exponents. For B, you divide coefficients, subtract exponents. And for C, the coefficient is raised to the power, so that's -5 to the third, which is where you get your -125. And then when you raise a power to a power, you multiply. Alternatively, we remember that this term cubed here means use it as a factor 3 times. So there's -5x cubed once, twice, 3 times. And then I apply what we developed, which says you multiply coefficients, add exponents. Either way, you come up with 125x to the 9th. Okay, here's today's do it. Stop and start, fill it all in, and then I'll go over the correct answers with you. Okay, first one, what properties illustrated? In this case, you'll notice that the 8 is changing who it's being grouped with. Anytime you change grouping and have a quality, it's the associative property, in this case, of addition. Next one, simplify. I've got to do the distributing of the 5 and the double distributing at the end, and then combine like terms. So, I mean, I assume you're completely done with this, so I can just put up the answer. The answer would be 16x squared minus 42x plus 30. Number 3, explain what adding fractions and lining up decimals has to do or has in common with adding puppy dogs and kittens. In this case, in order to add anything, fractions or puppies or whatever, you have to find a common category, or denominators or place values of those common categories in arithmetic with fractions and decimals respectively. Simplify by combining like terms. You get the idea. This is important. We hit it enough. Okay, 2x squared plus 2x plus 3. Simplify each using the laws of exponents. And as I mentioned a moment ago, in A, you multiply coefficients, add exponents. In B, you also multiply. Oh, it's divide. I'm sorry. You divide coefficients, and there's your division right there in case you missed it. You divide coefficients, subtract exponents. And for C, you take the coefficient and do it to the exponent, as would make sense. And then when you raise a power to a power, you multiply. So negative 64 n to the 9th. So this is a really good summary of most of the skills that we've learned so far. We don't do every skill every day, but that's a good start on what we've been doing so far. Now we're just going to take a bit of a sidestep and talk about praxis power. Performance is a function of preparation. So these are some types of questions that often appear on the praxis test that we want to make sure you are prepared for. And we get a little ahead of ourselves sometimes with these questions. However, by the end of the semester, it'll all make sense, if it doesn't already. Okay, try this one. Stop and start. Okay, so if two sides of a triangle have a length of 4 and 10, the third side could be, well, I'll give you a for instance. It could never be choice 3, which is 16, because then the 4 and the 10 only add up to 14, and the sum of any two sides must be bigger than the third. Remember, we talked about that straight line distance being the shortest. Let's see. The correct answer is 8, because 4 plus 8 is bigger than 10, 10 plus 8 is bigger than 4, and 4 plus 8 is bigger than 10. The 2 doesn't work because 4 and 2 are not greater than 10. We just explained the 16 before. And 4 and 4 are not greater than 10. So choice 1, 8 is the correct answer. Okay, try this guy. Okay, a little bit of inscribed angle work here, but you should remember that a central angle, angle AOC, is always equal to the arc. And that makes sense, right? Because there's 360 degrees all the way around the center of a circle and on the outside. So they should be equal. That makes sense. The inscribed angle, angle B, well, that's on the edge of the circle, and that's where I could form a triangle with points A and C, and that adds up to 180, so that has to be half the measure of the intercepted arc. So if angle, and we're going to work this a little backwards here, if angle ABC is 24, then that means that arc AC is also 24, which makes angle AOC 24. The measure of angle B is half the measure of arc AC. We're sure of that because B is inscribed. So the measure of angle B is 24, so the arc has to be 48. And then angle AOC is a central angle, so it equals the arc, so 48 is the correct answer. All right, here we go. We got a little Pythagorean theorem opportunity here, right? That's a right triangle. They don't draw the little right triangle there, but it is. Give it a shot. Stop and start. Oh, man. Every time I touch 2 fingers to the tracking pad, it goes backwards. All right, so here we go. Leg squared plus leg squared is hypotenuse squared, or a squared plus b squared is c squared. So 6 is a leg, b is a leg, and 10 is the hypotenuse. I know that because the hypotenuse is always across from the right angle. We have the right angle here in the lower left corner. Across from that's the right angle. So 6 squared plus b squared is 10 squared. 36 and b squared make 100. Subtracting the 36, b squared is 64. Square rooting both sides, b is equal to 8. I think like every test that I can think of, state or national, at some point on that test references the Pythagorean theorem once you have covered the Pythagorean theorem, which in New York State would probably start in 7th or 8th grade, definitely by 8th grade, possibly 7th. And you'll see it somewhere on your algebra regions, somewhere on your geometry regions, somewhere on your trig regions. It is used in calculus. It's used all over the place. All right, we got a little name your property, and hopefully I didn't screw up. Oh, this is not a matching one. You just write the name of the property next to it. Go ahead. Little stop and start action here again. So remember, when we go over properties, we want to look at the situation and relate it to the definition of the root word of each of the properties. So for instance, I look at the first one and I see that we're changing who the 3 is being grouped with. And the word that has to do with grouping is associate. So this is the associative property of addition. The next one, oh look, I'm giving out the 7 to the 4 and the 5. The word that comes close to give out is to distribute, so that's the distributive property. Next, also the distributive property. The difference between the previous one and this one is, on this one, I actually multiply it out to get 9 times 5 is 45. Next, oh look, we're switching order. The X and the Y, and then the Y, then the X. To switch, the word that relates, so the root word to switch is commute. So that's the commutative property of addition. The next one, oh look, orders. We're changing what's being grouped here. In the first part, the A is being grouped with the B. In the second, it's being grouped with the 7. They are equal. So that's the associative property of multiplication. And finally, again, we're switching order. ACCA, the word that is about switching, is commutative. So this is the commutative property of multiplication. All right, so we got our properties and more importantly, the ideas behind the properties, I think, down pat. Let's take a look at the next step, which is the new material for today. We're going to talk about linear equations. Now, what you have to understand about an equation is it's like a scale, a linear equation. The idea is to isolate the variable on one side of the scale so that we can figure out its weight, so to speak. When you get the variable on one side and a number on the other side, you have your final answer. The key is to make sure that if we change one side by a certain thing, we change the other side by the same exact thing. There's a picture of an equation looking like a scale. So these are very simple equations to start, what I call standard two-steppers. Let's try number 1. Again, I think everybody should have a clue as to how to do these from days past. So try number 1. I'll give you the correct answer in a moment. So we want to isolate the x, get it all by itself. So the first step is add 1 to both sides. That's 8x is 24. Still don't have the x by itself. So when I'm looking to isolate things, I'm always undoing. I'm doing the opposite or the inverse operation. So in the first step, we always attack plus or minus first. It says -1, so we do the opposite and we add 1. Then it says 8 times x. The opposite of multiplying is dividing. So I divide by 8 both sides and I get x is 3. The one thing you do not want to do here is say to yourself, oh man, 8 times what number subtract 1 is 23. That kind of thinking, as my pastor at church would say, is stinking thinking. We don't want any part of that, okay? We want to look at this as you operating with the inverse. Always do the opposite of each operation. Okay, try number 2. Give it a shot. Okay, so remember we always start with the plus or the minus, the addition or subtraction. So I'm going to do the inverse of add 4, which is to subtract 4. There it is. That leaves me with x over -2, which means x divided by -2 is 11. The opposite of to divide by -2 is to multiply by -2. And you can see I do that on both sides. Now on the left, -2 over -2 is 1, so I can just cancel them out. And that leaves me with x is equal to -22. Okay, try number 3. All right, on number 3, this is a little tricky. The reason it's tricky is because the way things are is or are placed in the equation is awkward. Now, let me just take a step back for a moment. What's the difference between Mr. Jones and Mrs. Jones? Well, one's a boy, one's a girl. How do you tell which is which? Well, the way you do that is you peek in front of the Jones part of the term. If it's Mr. Jones, then it's a boy. If it's Mrs. Jones, then it's a girl, because Mr. denotes boy and Mrs. denotes girl. It's the same exact thing with numbers to determine if they're a positive or negative. So I peek in front of this 10 and I see no sign. So in seeing no sign in front of the 10, then that says to me, okay, that's a positive 10. Likewise with the 4, I see no sign in front, so that's a positive 4. And with the 3x, I do see that negative in front, so that's a negative 3x. Now that's really important because a lot of students for their first step will mistakenly add 4 to both sides because they see the subtraction sign or negative or minus sign here. That's not true. The 4 has nothing to do with that negative sign. The negative sign has to do with the 3x because it's in front of the 3x. Just like Mr. Jones and Mrs. Jones are in front of Jones, and you tell whether it's a boy or a girl by Mr. or Mrs. With the 3x, you tell if it's positive or negative by peeking in front of the 3x. And for the 4, you peek in front of the 4. So this is a positive 4. So the correct step is to add negative 4 or subtract 4, however you want to look at it. It's the same thing to both sides. 10 minus 4 is 6 equals danger, danger, danger. Do you guys know who Steve Irwin is? I hope so. He was known as the crocodile hunter. He had a show on Animal Planet. And he used to, like, he was a crazy guy. He would pick up like a black mamba snake and he would go, oh, danger, danger, danger. One little bite from this beauty, you're a goner. And then he would like pet the snake and hold the snake. And I'm like, oh man, you're out of your mind. So in this particular problem, the danger here is so many students, when they bring down this 3x, will just bring down a positive 3x. And they forget that it's the 3x that's negative, okay? So what you want to do is bring down the negative 3x, make sure you have the negative 3x here, and then divide both sides by negative 3. And you get x is negative 2, or negative 2 is x, even a little better said that way. Okay, try number 4. Puts all of the ideas in these first 3 questions on this page together. Go ahead. Okay. So we just discussed before how this 12 is positive, so I add negative 12 to both sides. It's just how I prefer to look at it, but you could say I subtract 12. 22 minus 12 gives me 10. The x is being, and now careful here, danger, danger, danger. That's a negative x and 5. So to get rid of that negative sign, I'm going to multiply both sides by, look, I made a little bit of a mistake here. Yeah, no, I did it right. I'm going to multiply both sides by a negative 5. And that gives me x is negative 50. I couldn't find the negative on the right-hand side, but it must be under there because I have it on the left. Okay, now, the next thing we do is we get into slightly more complicated equations. And for this, let me do some teaching first. I would like to do number 1 first, and then give you guys a chance to work on number 2. Anybody in here, anybody in this class like football? So when you play football and the quarterback comes up to the line of scrimmage, he takes a look at the defense and he'll go like, blue 28, hot, hot, hot. And he'll look at the defense. And what he'll do is he'll see, for instance, maybe the defense has 3 guys set to triple cover your best wide receiver. So you can't throw the ball to him with triple coverage. I mean, you could, but it's dangerous. And on the other side, there's a receiver that's wide open. So then the correct strategy for that defense to apply to that situation that the defense is showing you is to pass it to the guy that's not covered, even though he's not your star receiver. When we look at equations, we need to see what kind of defense the equation is, so to speak. We need to see what type of equation it is. So when I look at number one, what I notice is that the variables, the x's, are on both sides of the equation. Whenever variables are on both sides of the equation, I like to think that it's an opposite side situation. So I would say opposite side, opposite operation. So what I do is I notice that the 4x's are on both sides, and I don't want the 4x's on both sides. So I'm actually first going to actually subtract 4x from both sides. So I focus first on the variables. I see they're on both sides of the equation. When they're on opposite sides of the equation, I do the opposite operation. That's a positive 4x. I do negative 4x to both sides. That leaves me with 4x minus 1 is 23. Now, you've actually been doing this all along with numbers, just not with variables. Because when the numbers are on opposite sides, you do the opposite operation. That's where the minus 1 becomes plus 1. And I get 4x is 24, dividing by 4, x is 6. Let's have you try number 2. Do a little stop and start here. Go ahead. Okay. Now, 5x and negative 2x are on opposite sides. That's the first thing I notice on it. Like if I'm the quarterback coming to the line of scrimmage and I'm looking over that defense, what I notice first is that the variables are on opposite sides, and I say to myself, the correct call here, the correct play is opposite side, opposite operation. So 5x negative 2x, I do the opposite of negative 2x, add 2x. 5x and 2x makes 7x, minus 8 is negative 22. Then the opposite of negative 8. Remember, when I do this with variables and I do the opposites, because you have had, it's just like you have had opposite numbers, where numbers are on opposite sides, and done the opposite operation for the longest time. We are just doing the same thing with variables. It doesn't matter if numbers are on opposite sides or variables are on opposite sides. We treat them the same. Opposite side, opposite operation. So this says minus 8, we do plus 8. That gives me 7x is negative 14. Multiply by 7, do the inverse or opposite, divide by 7, and I get x is negative 2. So the big takeaway from numbers 1 and 2 is whenever the variables are on opposite sides, we do the opposite operation. In so doing, we're simplifying one side of the scale. If you take a look at the first question and envision this as a scale, when I do the opposite with the negative 4x, the right side of that scale is getting closer and closer to having just a final number on it. Okay? That's the strategy here. Opposite side, opposite operation. Now, number 3, take a look at that equal sign. When we say opposite side, opposite operation, we're always meaning opposite sides of the equal sign. Number 3, this is not opposite sides of the equal sign. In this case, the variables, the 3n and the 2n, are on the same side of the equal sign. So we say same side, same operation. They're on the same side. Just do what it says. 3n plus 2n is 5n. So I get 5n plus 7 is 22. Minus 7 to both sides. 5n is 15. Divide by 5, n is 3. That's the correct answer. Okay? You try number 4. Okay. We notice right away, we're looking at these n's, and we see that they're on the same side of the equal sign. Same side, same operation. I think I mentioned once that I was cut from a church choir, which I was. It was pathetic. I'll tell you that story in just a minute. 41 equals negative 9 plus 10n. Same size, same operation. Add those n's up. The opposite of negative 9 is positive 9. 50 is 10n. Divide both sides by 10, and I get n is 5. All right. So let me tell you the story about the first time I ever spoke in public. This is a great story to illustrate to you that you are capable of anything in your life. So I was actually born in a town called North Babylon on Long Island. And my parents lived there until I was in fifth grade. And I have two younger sisters. So my parents moved the family out to a fantastic town called Blue Point, which is linked to Bayport. They're kind of the same community. An area called Bayport Blue Point. And when we got into Blue Point, it was in October of 1973. The Mets were in the World Series against the A's. And my parents wanted to, meet people and make friends. So they decided that they were going to join the church. And this was right around Thanksgiving. They were going to join the church. So a neighboring town is called Sayville. And there's a red church on the corner of Green Avenue and Montauk Highway in Sayville, which is Main Street. So my parents decide they're going to join that church. It's a Methodist church. So they go into the church, they join. And at that time, they are doing a Christmas pageant. Kind of like the movie Simon Birch. If you've ever seen it, it's a fantastic movie. And if you want to see that movie, especially with the holidays coming up, please check out Simon Birch. It's a fantastic movie. I think you'll really enjoy it. Deep, profound, funny, provocative. Really good movie. So anyway, we move into this particular area, and we're getting into the church so that we can meet people. And my parents are like, okay, we got to make lots of friends here, and hopefully we impress them enough to make friends. You know how that is, right? You're going to college. You might be a freshman, experiencing the same thing now. So my sisters have musical talent. So they're immediately put into the pageant, this Christmas pageant. They get a little singing part in it, and so on and so forth. The lady asked me to come up and sing the notes on the piano. And she hits a note all the way on the lower, like the left end of the piano. She says, sing this note. And I went, she goes, let's try this one in the middle here. And I go, and she goes, let's try this one all the way on the right. I go, and she goes, yeah, the church needs help with other things. That's exactly what she said. Church needs help with other things. So here I am, stuck all alone, moved to a new town, and they won't even take me in the Christmas pageant. How pathetic is that? So they bring me up to the pastor of the church, and they say, this kid here, he's pretty smart, and he can write a little bit. What can we do with this kid with the Christmas pageant? So the pastor says, listen, I got an idea. Let's have him write a prayer to close all the whole service down. And they say, okay, that's a great idea. So I wrote the prayer, and I brought it in to see the pastor, and he looked at it, he goes, oh, that's a good prayer. Very good prayer. Now you practice that prayer. You practice it all the time, every day. And then when you come to give the prayer as part of the pageant, he said, you just speak into the microphone, and that'll close the whole service. After that, we'll go home. He said, but listen, just in case, sometimes when people get up to speak in a microphone in front of a large group of people, they get a little nervous. So make sure you bring a copy of the prayer with you up there, and then you can just read the prayer if you forget what it says. So the Christmas pageant goes off without a hitch. My sisters are stars. My parents are sitting there in their seats with their chest puffed out like, yes, we're part of the community. Look at this. We're making friends. This is good. And then it's time for the pageant to close. I walk up to the podium, the pulpit, and I look down. And I see the world's biggest Bible. It was huge. Covered the whole pulpit. And then I look up. And I see everybody looking at me. And I go, dear God, you can figure out the word after that. And then, like, everybody just looks at me like their jaws drop. And I go, oh. So I reach into my pocket, and I pull out the pocket. And when I pull out the prayer in the pocket. And when I pulled out that prayer, I ripped it, and I went, oh, God damn it. Oh, my God, the whole church, all of their faces looked at me, silence in the room. And my parents went from proud of their daughters to shrinking in their seats. And I was like, oh my God. Oh, what a disaster. So I thought my dad was going to kill me. He was not averse to taking out the belt, which is, I don't think it's a big deal. But anyway, and we got out to the car. My dad was fuming. And my mom stepped between my dad and I. And she said, my dad's name was Bob also. She goes, Bob, you can't hit him because we talk like that around the house all the time. And my mom was right. So the moral to the story is this. If you can be as pathetic on your first attempt at what would become your future job, public speaking, I get paid to publicly speak. I have a fly fishing club in San Diego who's flying me out to San Diego to speak at their meetings. I've gotten so much of this down pat. And look at my beginnings. Horrible. Awful. So whatever it is that you want to improve at, get better at, and conquer, I think you got a really good shot at it. I certainly worked out okay. All right. So let's go do this slide. But I have a little bit of an issue with this slide because I need to do something here. So I need to correct something here. So look away for just a second, okay? Oh, man. Animation pane, good, delete. Fly in. This is how a trained professional handles an emergency situation. That's what we're showing you right now. And ta-da. And now we will go back to the slideshow and play from the current slide. Okay, good. Now you can do all 4 of these problems because you don't have the answers in front of you. Don't go back and look. Do all 4 of these as a stop and start, and we'll go over them when you're done with all 4. So you will notice on the first one that we have a little bit of a combination of same side and opposite side in the same problem. This is how it usually works. Your very first thing you want to do, realize that you have the 7x, the negative 5x, and the 1x on the same side of the equal sign. Same side, same operation. I always look for that first. So 7x minus 5x is 2x plus another x is 3x. So I get 3x minus 8 is equal to x minus 24. Then the x's are on opposite sides. So I do opposite operation. Subtract x because this x is positive. Remember that negative sign after the x has nothing to do with the x. It has to do with 24. So minus x to both sides. 2x minus 8 is negative 24. Danger, danger, danger. Don't forget that negative sign. Add 8 to both sides. 2x is negative 16. Dividing by 2, x is negative 8. Number 2 is like unto it. What you will notice is that the 5x and the negative 8x are on the same side, same operation. And what we want to make sure of is that we do that before we do opposite sides. So negative 3x, 5x minus 8x is negative 3x, plus 1 is negative x minus 27. Okay. Now, when we add or subtract the x's to both sides, it's not about left side, right side. Okay. That's why I made this question up. You want to always attack the smallest number of x's whenever possible because that means you'll be doing less multiplying and dividing by negatives. And we don't want to multiply and divide by a negative if we can avoid it because it's a slightly increased chance for a sloppy mistake. So the first thing I do here is add 3x to both sides. And I get 1, that's a positive 1, is equal to 2x, right? Negative x plus 3x is 2x, minus 27. Then I do opposite side, opposite operation with the negative 27. So add 27 to both sides. I get 28 is 2x, 14 is x. Okay, now we get to number 3. And before we can do anything on number 3, we have to distribute the 3. Okay, so I'm going to distribute it to both terms there. And I get... Oh, I did a step in my head here. All right, let's talk about what I did in my head. 3 times n is 3n. 3 times 5 is 15. So 3n plus 2n's gives me my 5n's, or I wrote x's. So I got 5x. And then 3 times 5 is 15, minus 4 is equal to, oh, look, this is the same one as, oh, this is copied wrong. All right, we're going to skip number 3. I put the wrong, see, I put that wrong answer sheet there. Darn it, sorry about that. We'll skip number 3. We have a million of these coming up, so we'll be okay. Number 4, I distribute the 5. Oh, look, I did it all for these. Wow. How bad is that? All right, I'll tell you the correct answers to numbers 3 and 4, and I apologize greatly for having put the wrong answer in that place or how to do it the wrong way, or the correct way, but for the wrong problem. 3n, 5n, 11, 10. Let's see, 3n and 2n make 5n. Add 3n would be 8n. 8n is equal to 10. I'm going to get 1.25 or 10 over 8 or 5 over 4. And for number 4, 8n, 2n, 10n, wait, 10, 12n, minus 15 plus 6 is minus 9. I get 9n is equal to 36, so n is equal to 4. I apologize greatly for that mistake. I really don't know how I made that mistake. Okay. Now, what's the difference between solving an inequality and solving an equation? So here's some work shown here. Ready? Negative 3n minus 2n plus 7 is less than or equal to 22. I do the same exact process or strategy. Negative 5n plus 7 is less than or equal to 22. Subtract 7 from both sides. Negative 5n is less than or equal to 15. So far, it's the same. You just treat the symbol in between this less than or equal to exactly the same way that you would treat an inequality sign. But whenever we multiply or divide by a negative, and this is one of the great things about that way I showed you about remembering the rule that whenever you multiply or divide by a negative, you switch the sign of the number you started with, but also you switch the sign in an inequality. So I divide both sides by negative 5, and I get n is not less than or equal to negative 3, but greater than or equal to negative 3. Now, why does this make sense? This makes sense because whenever you negate something, you make it its opposite. So if I had less than $5 in my wallet and I negated that, then I would have greater than $5 in my wallet. So that's why every time you divide or multiply by a negative with an inequality, you switch the sign. So that's kind of disjointed, but I wanted to bring that to your effect. Whenever you solve an inequality, it's virtually the same as solving an equation, except with the step that if you multiply or divide by a negative, you have to switch the sign. All right, let's see you do the first and second questions only. First and second only, then we'll go over those, and then we'll do the third and fourth. So try the first and second. Okay, so for this first one here, I see an opposite side, opposite operation situation. Whether it's an inequality or an equation, I still have the same strategies. If it's an inequality, I just remember that if I multiply or divide by a negative at the end, I have to switch the sign, which by now should be becoming a part of how we understand mathematics, because that principle of having a negative or negating and switching the sign it permeates our understanding. So I subtract 4x from both sides. That gives me 4x minus 1 is less than 23. Then this is an opposite side with the negative 1, so I add 1 to both sides. 4x is less than 24. Dividing by 4, x is less than 6. This is just like an equation that we did before, except now we have an inequality. One big difference with an inequality, here's two of them, right? Two big differences, the only two big differences. The first one, with an inequality, you get lots and lots of answers, infinite number of answers. With an equation, you get one answer and one answer only. See, you might think the answer to this question is 6. It is not. when you begin an equation like x minus 1 equals 4x plus 23, you're saying what's the one and only one equation or number in the entire existence of numberland that satisfies the equation, and that would be 6. But when I solve the inequality that says 8x minus 1 is less than 4x plus 23, the truth is that now I get x is less than 6, which means that it's any number that's less than 6. So for example, 5 is a solution, 5.5 is a solution, 5.99, negative a billion, 0, negative 5, positive 5. All solutions because they're all less than 6. What's not an answer to this? 6 is not an answer to this because 6 is not less than 6. Neither is 7, 8, 9, and so on. But for a number to be an answer to this, it must be less than 6. Now, because there's so many answers and they won't all fit on the answer space, like if you're doing an equation and there's one answer, the answer is 6. Okay, put it in the equation. Put it in the answer space. You don't need to write x equals 6. There's only one answer. When you put a 6 there, we assume that's what you mean. But when you're doing an inequality, you need to put all of the parts. So you need to include the x, the symbol, and the 6. You need to write that in the answer space. If you don't have all three parts, then your answer is not correct because it's incomplete. Okay, try number 2, and let's hopefully remember to make sure that you put all three parts in your answer. Go ahead. Oh, I think I remember you did it before. Well, you could have checked over the three parts. Now, opposite side, opposite operation, add 3x to both sides. That gives me 8x minus 8 is greater than or equal to negative 24. Adding 8 to both sides, again, that's opposite operation. I get 8x is greater than or equal to negative 16. Then I divide by 8, and I get x is greater than or equal to negative 2. Notice with this, I divided by a positive 8. So I don't change the sign because I multiplied it or divided by a positive. I don't care, I should say, that I divided into a negative. That's irrelevant to me. It's only what I multiply or divide by. Divided by a positive, don't go changing any signs. Your answer must have all three parts. X is greater than or equal to negative 2. What are some answers to this question? Right? What about 0? Is 0 an answer to this question? Sure, 0 is greater than or equal to negative 2. What about 1? Yeah. What about 101? Yeah. What about negative 1? Yeah. That's greater than or equal to negative 2. What about negative 2? Yes. Negative 2 is greater than or equal to negative 2. So how come the negative 2 is an answer in number 2, but not 6 in number 1? The reason's really simple. In number 2, the answer is not strictly greater than. It's greater than or equal to, so you could equal the negative 2. In number 1, that answer is strictly x is less than 6. There is no line underneath to say or equal to. Okay, so let's try numbers 3 and 4 now. Go ahead. Okay, I'm sure you did your stop and start on number 3. I got negative 3 n's and negative 2 n's. That makes negative. Oh, man. Look at this. For some reason, I wrote positive 3n and positive 2n. Let's do the negatives, and I'll correct the answer at the end. Negative 5n plus 7 is less than or equal to 22. Minus 7 to both sides. Again, this should be negative 5n is less than or equal to 15. Divide by negative 5, and I would get n is greater than or equal to negative 3. Again, n is greater than or equal to negative 3. So listen to the verbal on that rather than following or just looking at what was described or described. N is greater than or equal to negative 3. On number 4, I get 41 is greater than negative 9 plus n plus 9n. Same side, same operation. N and 9n make 10n. That 9 is negative. Do the opposite. Add 9 to both sides. I get 50 is greater than 10n. Dividing by 10, I get 5 is greater than n. But we don't typically leave it like that. Typically, it's correct, but we like to put the n on the left for graphing purposes, which we will get to at some point. So I'm going to put the n on the left. And the rule here is when we switch this is if it points to the n here, it's got to point to the n here. Why? Always asking why in this class. Well, the statement 5 is bigger than n is the same exact statement as n is smaller than 5. Okay? 5 is bigger than n is less than the 5. So that's what we're really saying here. And we like the n on the left because it allows you to graph it easier. Very quickly, just remember we always want the n on the left with an inequality answer. And whenever we switch it around, it's got to continue to point to it. So if it pointed to the n here, it's got to point to the n here. And that'll be your correct solution. Differences between equations and linear, inequalities and equations. First, an equation has one and only one answer. Inequalities have an infinite number of answers. 2, a correct answer must have the variable on the left, symbol and number, not just the number when you do an inequality. Number 3, if you switch sides, the arrows point to the same thing. That's what we just did where it had to point to the n both times. And if you multiply or divide by a negative, you must switch the sign. For example, if I have n is less than 9 and I switch it around, I get n is greater than 9. If I had 9 is less than n, 9 is less than n. When I switch it around, n is greater than 9. Points to the 9 here, it's got to point to the 9 here. Those are the big differences. Now, graphing inequalities. Let's talk about these and what the correct answers are, what they should look like. First, if I wanted to graph n is greater than 4, notice I said we always want the n on the left when we graph the solution because the arrow, when you graph it, will go in the same direction as the inequality. In fact, the greater than and less than symbols are actually the ends of the number line. See, this is a greater than symbol because it's the end of the greater end of the number line. Okay? So this is n is greater than 4. It's not allowed to equal 4, so I do an open circle at 4. I don't fill it in. And then I do arrow to the right. This is n is less than 4. Open circle at 4, arrow to the left. This is n is less than or equal to 4. Same exact graph, except I fill that circle in. And then there's n is greater than or equal to 4. Same exact, fill the circle in, arrow to the right. As long as the variable's on the left, the arrow that you draw coming off the critical point of 4 is going to go in the same direction as the inequality points because it comes from that arrow. Okay? Now, looking at these first 4, I also want you to know that there's another way of writing this with interval notation right here, or bracket notation, whatever you want to call it. I start at 4 and I go all the way to infinity. I'm not allowed to equal 4. If I'm not allowed to equal 4, then if I'm not allowed to equal the 4, I put a parenthesis. If I am allowed to equal it, I put a bracket. Okay? Pretty cool reasoning to explain with that a couple of minutes from now. The previous one, and remember, when we do this notation, we always start on wherever the graph begins on the left. So it begins at the 4. So parenthesis, because you're not allowed to equal the 4, comma, infinity. That means it goes from 4 all the way to infinity. It's not a coordinate geometry point. It's just begin at 4, go all the way to infinity. Number 2, begin at negative infinity. And there is no specific a point where like you're at negative infinity. You can always keep going further left. So we use a parenthesis. And then you're going to go all the way up to 4, but you can't equal it, so we use a parenthesis. Okay? But with the third one down, now we fill that 4 in. So again, we start at negative infinity, always a parenthesis whenever infinity is involved, and you go up to 4, but you are allowed to equal it. The reason you're allowed to equal it is because the circle is filled in. And the way I like a bracket indicates this, what we have here, a staple, if you want to call it that, indicates that you are allowed to equal the 4, as opposed to the one above it where it was a parenthesis, which indicates that you're not allowed to equal the 4. And the way I can remember that you are allowed with a staple or a bracket is if you take the top piece and the bottom piece together, they make an equal sign. So you are allowed to equal it. I remember to fill the circle in when it's like less than or equal to, because I take the extra ink from the equal sign underneath and I fill the circle in with it. So I take that extra ink right there, fill the circle in. Take the extra ink right there, fill the circle in, or some of the extra ink. The fourth one down, bracket notation, I have a bracket here or a staple 4 all the way out to infinity. And again, you can't equal infinity, so it's a parenthesis. Now, sometimes we only have an interval that we're doing. So -2 is less than n is less than or equal to 5. So the critical points are -2 and 5, so I put those on the graph. I'm not allowed to equal the -2, so that circle stays open. I am supposed to equal the 5, so I fill that circle in, and then I just connect the area in between. For the third one, the critical points are 3 and 7, and both of them are or equal to, so I fill both circles in, connected in between. How would I express these in the other notation? Well, I do a parenthesis at -2 because you're not allowed to equal -2, and I do a staple or bracket at 5 because you are allowed to equal 5. When I take a look at the one underneath that, the last one on the page, you're allowed to equal both, so I have staples or brackets on both. Now, solving and graphing. All right, so 2 times 4n plus 5 plus 2 times n plus 3 is greater than 17. And what I'm going to do very quickly is hide this. I'm going to have it fly in. And let's have you. Oh boy. Let's have you solve this problem. Go ahead. Solve and graph. Graph it on a number line. All right. I'm sure you did stop and start by now. I distribute the 2. I distribute the second 2. So 2 times 4n, 8n, 2 times 5, 10. 2 times n, 2n, 2 times 3, 6. Greater than 7n minus 17. 8n and 2n, combining those like terms, that makes 10n. 10 and 6 makes 16. Greater than 7n minus 17. Opposite side, opposite operation. I'm doing everything the same with an inequality there until the very end, possibly, maybe not. Inverse or opposite of 7n is minus 7n. That gives me 3n plus 16 is greater than -17. Subtract 16 from both sides. 3n is greater than -33. I'm dividing by a positive, so the sign stays the same. The negative of 33 will stay the same. -33 divided by 3 is -11. When I go to graph this, the n is on the left, so it tells me which way the arrow points. The answers are greater than -11. So critical point -11, I circle it. I do not fill it in because it's not or equal to, arrow to the right. Okay? Let's get this out of the way again too and hide this. Okay. I didn't know that I should have been hidden already, but now we got it set up. All right, try this one. Don't forget stop and start, so we'll go over this momentarily. Okay. All right, now distributing the 2 and then the other 2. 2 times n plus 5 plus 2 times n plus 3 is less than 7n minus 5. 2n plus 10 plus 2n plus 6 is greater than, I said less than before, greater than 7n minus 5. 4n plus 16 is greater than 7n minus 5. Remember, we always start, because this is an opposite side, opposite operation situation, we always start with the small number of n's. So I subtract 4n from both sides, and that gives me 16 is greater than 3n minus 5. Adding 5, I get 21 is greater than 3n. Dividing by 3, that's a positive 3. I don't need to change the sign. I get 7 is greater than n. But for graphing purposes, we don't want that. we want the n on the left. So I move the n to the left, the 7 to the right. If it points to the n here, it's got to point to the n here. 7 is bigger than n is the same exact statement as n is smaller than 7. Critical point is 7. Put an open circle there. Arrow to the left. Arrow goes in the same direction as the inequality as long as the variable is on the left. Okay, next one up. So let's, instead of erasing this one, let's just follow it through and see if we understand what's going on as we solve it, or as I solve it. Subtract 7 from both sides. I get negative 4n is greater than or equal to 16. Dividing by negative 4, I get n is less than or equal to negative 4. Why did I switch that sign from greater than or equal to less than or equal to? Why did I switch that? Because I divided by a negative. Anytime you divide or multiply by a negative, you have to switch the direction of the inequality. Happy recap. In algebra is an arithmetic with variables. You have, without knowing, been doing algebra since you first started doing arithmetic, and we did a whole lot of algebra in this particular problem. As far as property names, distribute, to give out, associative, group with, commutative, switch. The names of the properties are logical, and as you analyze what's going on the properties, you can understand which one is which. You've been using the distributive property for many years. It can make both arithmetic and algebra quicker and easier, and I did not mention here, or write it out, but I'll mention it verbally. We dealt with equations and inequalities today. With equations, you're looking at, is it a same side or opposite side situation? If you see same side, it's same operation. If you see opposite side, it's opposite operation. With inequalities, you do them the same exact way as equations, but if you multiply or divide by a negative at the end, then you have to switch the inequality. Okay? All right, so that recaps what we went over so far today. A quick reminder of ways to succeed in class. Make sure you do all of those homeworks. It's kind of like getting extra credit, but not exactly. How you go about your business is really the most critical thing, okay? Pay attention to the due dates on Moodle. Work together on projects. Collaborate and have pride in your work. And every day is a chance to dream, to realize your dream or not. If all you do when you go to college is party all the time, neglect your work, you really don't think you're getting closer to your dream, do you? Right? But if you make sure your work is done first and that your responsibilities are all taken care of, and then you have some free time, and in that free time you want to go enjoy yourself a little bit, then yes, you can absolutely do that. But if you don't take care of your work, then you do not get closer and closer to realizing your dream. Now, you're going to take your first assessment after today. This lesson, there is no second lesson this week. For the rest of the week, all you're going to do is work on this first project that I'm giving you, okay? We're also going to take a quiz in class as well. So it's time for your first quiz. Many of your assessments will be in multiple choice format, but this one is not. This assignment can be found posted on Moodle, where you can find the due date and a rubric detailing how it will be graded. Near the top of our page on Moodle, it'll say project rubric or something like that. Just download it and you can see what it is. Please feel free to work together on this assignment. Blatant copying will invite a follow-up from me. However, do the questions cooperatively and then submit your responses in your own words. That's fine. I don't care if 2 people or 10 people work together. Just as you do for homework, when done, take a photo with your phone and send it via the school email